Yeah, on Thursday, we saw something about data types, and we know what are data types now. And there are different kinds of data types, right? So we have like around Java defines 8 types of primitive data types. So they can be grouped in 4 groups. They are integers, floating points, characters, and booleans. We saw what are those integers. Integers are further classified into short, byte, int, and long. Floats, we know float and double. Characters, which are 16-byte Unicode characters. Booleans, variables which can take or data type which will have only 2 values, true and false. We also saw what are literals. Okay. We also saw what are literals. So literals are nothing but the values, right? The values of a particular data type, or you can call them as constants. The direct values that you assign to variable is variable are called the literals. Okay. So let's get started with our let's get started with variables. So we know that variables are used for storing data, right? So they are basically as a basic unit of storage. Okay. So because using those variables, we can access the data that we have stored in our memory locations. That is our storage. So those are defined or declared using the combination of identifier, a data type, and an optional initializer. Okay. So the important point to remember here is the important point to remember here is the initializer is optional. Okay. So the initializer is optional. Okay. So also we during the introduction I told like variables have a scope. They also have lifetime. Okay. There are 2 important points which needs to be remembered. Is one is the scope, and the other one is the lifetime of a variable. So we in one of our previous session we saw how to declare a variable. Right. So the syntax for declaring a variable is this one. Excuse my writing. It is a bit awkward, but I'm trying to learn this one so that it is a bit more interactive. Okay. So this is the syntax for declaring a variable. So we have the data type, the identifier, as we mentioned in this sentence. So it's a combination of a data type and an identifier. Okay. So identifier, actually here what we are doing, we are naming a variable. Okay. We are naming a variable. As we know, identifiers are used for naming classes, methods, variables, enumerators, interfaces, and so many other things are there. Okay. So here these are variables or values that are assigned to the declared variables. Okay. Here we have declared variable, and this is the value that we are assigning. Okay. So this is the data type that we have seen in our class on Thursday. Okay. It can be anything that data type which we declared. This data type can be both user-defined data type as well as primitive data type. Yeah. In our class on Friday, we saw primitive data types, and whatever the classes that we are creating for our test, right? We're actually creating a thanks on. Yeah, we're actually creating a I guess this was your suggestion, right? You had suggested Pawan. Yeah, trying to learn this. Yeah, so data type on Thursday's class we discussed primitive data types. Okay, so that as well as user-defined data type. Any user-defined data type we can use here to create a variable of that particular data type. Okay, and here we have optional values to assign. Okay, that starts with your equal sign and a value. The value should be compatible with the type of the variable that we declare here. Okay, so you can declare a variable, or you can declare multiple variables. Okay, multiple variables of a same data type, multiple variables of a same data type in a single line. Okay, in a single line. Say for example, I want to declare int I comma j. Okay, this is how I can declare, or I can declare like I j. Okay, like that also I can declare. Okay, so on the same line you can declare multiple variables of same data type. That is very important. Yeah, Pawan is asking a question. Is there a way to share the slides? Let me unmute you, Pawan. So I have unmuted you. What is your question, Pawan? Do you want me to share the slides before the class starts?
No. Actually, I just wanted to know if there's any way you can you can share the slides along with the video, because the people who attend the video, right, they'll have everything. I mean, they understand, right? So if they just go through the slides, it might be, kind of time saving, like it can be easier, right? Because they did not see the whole video to not so as to understand a few points, or in case they have to revise later, something like that.
Okay, I got your point. I think you are not getting the slides. That's what you are trying to tell, right?
Yeah,
not getting that.
Not the slide. I just have the video.
Okay, yeah, actually what we have been doing is we are sharing the slides as well as the videos. Okay, probably you might not have okay, I'll talk to Yuvraj regarding this one. Okay, you will get all the details with also the variables as well. Okay, I mean the slides as well. Okay. Okay, yeah. Yeah, there's a question from Abid. Yeah, that is what the question is. If I declare, this is the question that Mohammed is asking. Abid is asking. If I declare int I and j, will j become an integer? Okay, so that is what I'm highlighting here. Okay, this is what I'm highlighting. That is, you can declare multiple variables. Assume that this is variable 1, okay, this is variable 2 on a single line. Okay, how you can do that? The condition is all these variables should be of same type. Okay, you can't declare multiple types on a single line. It is not that say for example, yeah, I got your question. So what he is telling is int I, okay, and j. Okay, also what you can do, long L. This is all these things are in single line, right? But what we are doing, we are separating the declarations by a semicolon. Okay, we are separating the declaration by a semicolon. So when I'm telling you can declare multiple variables on a single line, it means I'm talking about same data type. Okay, and then you end with, let me, okay, so here what I'm telling, I'm not forgetting to end this with a semicolon. Okay, I'm not defining multiple data types here. Okay, I'm not defining multiple data types here. This is, say for example, if this is an int, so this will be I, comma, this will be j, and I'll end with semicolon. Okay, So after ending with semicolon, you can write another data type. Say for example, like I did, long L. Okay, this ends this particular statement, right? You know that, right? So any statement, I mean, you can write multiple statements. Okay, you can write n number of statements on a single line, or you continue writing. Okay, but each and every statement should be terminated by a semicolon. Okay. So what else is the other question? Yeah, to your answer, Rabit, if you declare int I comma j, j will also be an integer variable. Okay, and okay, yeah, looks like you are not getting the slides, but I have been sharing the slides. I'll talk to Yuvraj. Okay, no worries with respect to that one. Okay, yeah, let's move on to the next slide. I was okay. I'll talk to Yuvraj. Okay, so let's start with the identifiers. So we know that there are certain things that needs to be followed with respect to identifiers. We have not discussed those things till now. We know that we use identifiers for naming classes, methods, and variables. So it is similar to like we use names for our to identify each and every person, right? It is similar to that one. So what are these identifiers? They are nothing but a sequence of letters. Okay, sequence of letters or underscore and dollar sign. Okay, you can have any of these things, but the only thing that you need to remember is it should not begin with a number. Okay, so why it should not begin with a number? If it begins with a number, Java gets confused with as numeric literal. Okay, the moment it sees a number at the beginning of identifier, it starts to think like it's a number. Okay, so that is why the only thing that you need to remember is it should not start with the number. It can start with the uppercase letter, lowercase letter, or underscore, or dollar sign. Okay, for example, you can say okay. Please excuse me. I'm still learning, so it'll be like this only. You have to bear me for a couple of more classes about my handwriting. Okay, so this is an underscore, and this is a valid one. Okay, and you can start with dollar name. Okay, this is also a valid one. So anyway, we have seen multiple places where we have used characters, right? Here, and all these places. Okay, so and also as we've been telling, it's like Java is case sensitive. So what does that mean is, if you declare a variable of value, this is totally different from this one. Okay, so here V is capital or uppercase. Here all letters are lowercase. So value is not equal to value. Okay, because it is case sensitive. For that matter, it is not equal to this. Okay, all these three things are different. Okay, you can declare in any way. If you declare an integer with the name int value, you can declare this also with same and with this also. Okay, we will see all those things in like when we go to the practicals. Okay, so here next topic is the dynamic allocation. So what do you mean by a dynamic allocation? Dynamic is like on the fly. Okay, on the fly means when initialization. So we have seen like the initialization part while declaring is optional, right? Here we have seen initialization part is optional. So what we do is we assign a value to the variable when you declare it. Say for example, int I is equal to 10. Okay, so this is what is called as declaration as well as initialization. Okay, so what is dynamic initialization? It is also an initialization, but what you do is you assign a variable, or you assign a value to a variable on the fly, in the sense like sorry. So you assign a value on the fly when the program is running. Okay, this how do you do that? Using an expression. Here we have an expression. We have declared two variables, variable A and variable B. Okay, and initialized them with 10 and 20. Okay, but what is the value that C gets? C gets a value of 30. Okay, because we are using an expression here. On the right hand side we have an expression, and we have declared a variable on the left hand side. So what it does is here it is like A plus B, right? Yeah, I'll come to you, Abid. Let me finish this. So what is happening is we have equals, and this is the right hand side, and this is our left hand side. Okay, so what exactly happens is whenever the right hand side is calculated first or evaluated first. Okay, right hand side is evaluated first, and then the value of this expression, okay, is assigned to this particular variable. Okay, it is applicable to everything. I mean, user defined data types, whatever it is. Okay, so Abid is asking a question: can we use arithmetic operation symbol as an identifier? No, you can't use arithmetic operation. That's what I have mentioned here, right? You can use letters, underscores, and dollar sign. Okay, and also you can use numbers. Okay, for simplicity we can use, consider like letters, uppercase, lowercase. You can use underscore, you can use dollar sign, and you can use numbers also. The only thing that you can think of is you should not start with a number. That is the only thing that you need to remember. This is just a simple. If you see, there are around 8 to 10 rules. Okay, the only thing that you need to remember while declaring a variable is, for our simplicity, these are the things. Okay, letters, underscores, dollar sign. Okay, so the variable can be variable name can be started with your letter and dollar sign or underscore, and it can include it can be alphanumeric also, but it should not start with a number. That is the only condition you should remember. Okay, so what about dynamic initialization? Yeah, we use an expression on the right hand side. The expression will get evaluated first, and then the value will be assigned to your variable on the left hand side. Okay, that is what is dynamic allocation. So why do we call it dynamic allocation? We don't know what is the value of this expression, right? If you change the value of A to 20 and the value of B to 30, the value of C will be 50. How did we get? So based on the value that we pass to this A and B. So that is calculated on the fly or when the program is execution. That is why it is called as dynamic allocation, dynamic initialization. Okay. Let's move on to the next topic. So this topic is very, very important. Okay, so just try to listen to whatever I am telling. Whatever the doubts that you have, please raise your questions. Okay, raise your doubts, and then we will try a few examples. And after the class is done, try to explore more and more on this scope and lifetime. Okay, so we will see what are these scope and lifetime of a variable. So we started with the topic, I mean today's session, saying like two important things to remember about variables is scope and lifetime. Yeah, Pawan is asking a question. Panindra is asking a question. Okay, so we declared int C is equal to A plus B. Okay, So, but why did we call it dynamic? Okay, that's what I was trying to explain. So let me go back to the previous slide. Okay. Okay, so here what I'm doing is C is equal to A plus B. Okay, so this is an expression. Whole thing is an expression. We have declared a variable on the left hand side, and we have declared an expression on the right hand side. Okay, so what exactly happens in this situation? So assume that we have 10 and 20 for A and B. Okay, the value of A and B will be calculated first, and then that value is assigned to C. Okay, assume that I will change the assume that this is a these two are parameters of a method. Okay, parameters of a method. Assume like add. I have declared a method called add int A int B. Okay, and I have these two things. So I'm returning this C. You will see all these things. Okay, so assume that I am passing initially. I am passing. Sorry. Okay, assume that initially I am passing 10 and 20 to A and B. Okay, the value will be 30. Okay, while calling that method. Okay, so next time what I will do, I will again I told like I am returning this value, right? Return C. Okay, so next time what I will do when I am calling that method, add method, I will pass 20 and 30. Okay, the value of C will become 50. Now the value of C will become 50. So as you change the value of A and B, the value of C will change, right? That is, you will not know during the execution of program what value you are getting and what is the value of C. That value of C will be calculated on the fly. Okay, that is why it is called dynamic initialization. Okay. Yeah, thanks, Phanindra. Yeah, we saw like two important attributes that are associated with variables are scope and lifetime. Okay, we will see what are those things now. Okay, the scope and lifetime is very, very important, and we will see in examples how when a particular variable gets initialized and when when the variable life starts and when it ends. Okay, in Eclipse we will see how that is done. Okay, how we can see that one. Okay, so in Java what happens? We can declare variables within any block. Okay, we can declare variables within any block. So we already know that in one of our sessions we saw like blocks, code blocks, right? In one of the sessions we saw code blocks. So how do we define code blocks? With open and close flower brackets. Okay, so this is the one. Open and close flower brackets. Okay, so whenever you open and close the flower bracket, what happens? That block defines a scope. Okay, that block. This is a open and close is a scope. We will see what is the scope. Okay, so a scope determines what objects are visible to other parts of your program. Okay, it determines what objects are variables are visible to your other parts of your program. Okay, say for we will see with an example. Okay, what I'll explain it with in detail with one of the examples. Okay, and it also determines the lifetime of a variable or objects. It also determines the lifetime of a variable or object. Okay, we can see this particular lifetime in Eclipse. Okay, in Eclipse. I'll show how to do that one. Okay, in Eclipse you will see clearly how to see the lifetime of a variable. Okay, then so in Java, what exactly happens? Java defines two major scopes. Okay, in the form of our class and a method. These two are the major scopes that Java defines. We know that class and we have a method, right? Method. Okay, so this is our class scope, this is our method scope. Okay, in our today's class we will concentrate only on method scope. We'll try to understand more about class scopes when we exclusively take a class on our session on classes. Okay, so one of the important rules that we need to remember about variable scope is this part. This is very, very important. Okay, so what it says, a variable declared within a scope, variable declared within a scope are not visible to the code that is defined outside of that scope. Okay, the variable defined within a scope is not visible to the code that is defined outside of that scope. Okay, say for example, okay, let me do one thing. Let me take an example and show it to you. Okay. Okay. Can you all see Eclipse? Hope you all can see Eclipse. Yes. Okay. Is it visible? Okay. Okay. So what I'll do is, okay. I'm trying to make it my mouse pad is a little different, so trying to figure out how to do that. Give me a second. Not this one. Give me a second. Yeah. Edit. Yeah. Give me a second. Command editor. Yeah, anyone knows how to make it big? General appearance, colors, and fonts, preference page. Cool. And appearance, general, okay, cool. Appearance, colors, colors and fonts. Okay, font preference page. Mhm. Is it fine now? Thanks, Anindra. Okay, so what we are doing is we will declare the two variables. Int I is equal to 0, int j is equal to 10. Okay, instead of that one, yeah, thanks, Anindra. Yeah, instead of that one, what we can do is int I, so int a comma b. Okay, like that also we can declare. What we have done here, both a and b will become integers. Okay, the two variables of type integers. So what I can do, this is your initialization. Okay, say for example, you have declared int I and assigned a value 0 to it, and you have declared j and initialized it with value 10. Okay, here I have just declared it. I will initialize the variable set like 20, b is equal to 30. Okay, b is equal to 30. So this is your declaration and this is your initialization. Okay, so now what I will do, I will try to do a dynamic allocation, dynamic initialization. Int c is equal to a plus b. Okay, so this is what, like, say for example, I will say this is one thing. Okay, I will print. I have one function, print function. Okay, so print. I have defined that function here so that and when you define like that, you need not have to type in system.out.println every time. Okay, for printing. Okay, so what I'm typing, value of a comma b comma c. Okay, so a b c. Okay, so let me run this so we can see those values here, right? Those values. So since a and b is 20 and 30, the value of c is 50. Okay, so I want to declare one more. I will assign value a is equal to 30, b is equal to 40. Okay, and int b is equal to a plus b. Okay, so when I run this, the value of d will be different, 70, right? So based on the values that are there in a and b. Okay, that is your this one, whatever, that is what is called as dynamic allocation. Okay, so as I told you, two important scopes are defined by Java are your class scope. Okay, this whole thing is a class, and then you have method scope. This is a method scope. Okay, so whatever we will concentrate today on our method scope. Okay, say for example, you have defined your integers here. Okay, you have defined your integers here, and if you want to access the values, okay, that is what the scope defines. Okay, scope defines your visibility or accessibility. Okay, scope defines visibility and accessibility. How do you define a scope? By defining or by opening and closing your curly braces. Okay, by opening and closing your curly braces. That's how you define a scope. So what happens when you define a variable within a scope? Okay, as we have seen in the first, like in our previous slide, when you define a variable within a scope, those variables within a particular scope are not accessible outside of the particular scope, be it within your method scope, be it within your class scope, okay, be it within your anonymous scope. So there are so many things to observe in this program. Okay, I'll explain each and everything. Okay, let me complete this. Yeah, visibility, Panindra, visibility is nothing but your accessibility only. So where exactly, which are all the code that can access a particular variable is nothing but your visibility or accessibility. Okay, so when you say accessibility, like people or code, then we will discuss about those things like public, private, all those things. Okay, so scope defines your visibility or accessibility. Visibility in the sense like who all can see that particular variable within a particular scope. That is your open and closed flower brackets. Okay, that is what is your visibility, which in turn tells like who can access. If somebody can see, or some other part of your program can see those variables, that is what you say like it's a visibility, right? So if why are those why we say those are visible? We say when somebody is looking at you, they like they want to do something with that variables, right? That particular variable. So if it is visible to particular set of code in your program, they can do something with those, or they can access or modify those particular variables. Okay, that is why we say either it is visibility or the accessibility of a variable. Okay, that is your scope. We will see what is lifetime of a variable. Okay, so that is what your visibility or your scope. So as we mentioned, by opening and closing your curly braces or flower brackets, we define a scope. Okay, let us define a variable here also. Int k is equal to 10, L is equal to 40. Okay, so k and L are integers. Okay, I'll print those values. Okay. K, L. Okay. K and L. So let's try to run this program and see what is happening. Okay, so we can see the values of K and L, 10 and 40. We can easily see the values 10 and 20, right? So this is nothing but your anonymous block. So this is your method block. Okay, so what is the general rule which says? So we just saw one general rule, right? So the general rule says variables within a particular scope. Okay, we saw this one. Okay, the general rule says a variable declared within a scope or variables declared within a scope are not visible to the code that is defined outside of that particular scope. So here, so the variables defined within a scope, let us consider this particular scope. Okay, the variables defined within this particular scope, the general rule says the variable defined within this particular scope is not visible to the scope or the code that is outside of this particular scope. Okay. Yeah. Once this is done, I'll explain your or I'll answer your question a bit. Okay. So the variables defined within this particular scope is int I, k and l, right? So as per the general rule of Java, for variable scope, these variables, that is k and l, should not be visible to the code that is outside of this particular scope. Okay. Let us try to print the values of, let us see by printing the values of k and l outside of that particular scope. Okay. Let us try to print the same thing. So here we can immediately see the errors. Okay, compile error. Says multiple markers at this line, that is k cannot be resolved to a variable. Okay, and then l cannot be resolved to a variable. I'm not sure whether you are able to see the message that is being displayed. Okay, so it clearly says these two are not visible, or it says like it cannot be resolved to a variable. Okay, says clearly, it says k and l cannot be resolved to a variable. Okay, that means we have defined k and l within this particular scope. Okay, they are available or they are visible only within this particular block of code. They are not available outside of this block of code. Okay, outside of this block of code. And another important thing is, in Java, if you want to use any variable, you have to declare a variable. Okay, for example, say y is equal to 20, so z is equal to some value. Okay, into y comma z. So what I have done here, before declaring a variable, I have assigned values to them. It is not allowed. Okay, so what you have to do, you have to declare a variable before accessing them or before using them. Okay, so if I change this to here, it is valid code. Okay, if I change this to here, it is not valid. So important thing is you have to declare a variable before you use it. That is the important thing. Okay, so let me come to Abid's question. So why do you write two plus symbols before and after variables? One is for string concatenation and why is the other? Okay, that's a good question. Okay, so what I'm doing here, so we have seen, right, concatenation operator. Okay, plus is I'm just referring to one particular concept in C++. Okay, not in C, it is C++ concept. Okay, that is called as you can do this thing. Okay, just for your reference, with respect to this only for plus. Okay, with respect to this plus, I am just referring to C++. There is something called as operator overloading in C++. Okay, operator overloading is nothing but you give a different meaning or you define something else for a particular operator. For example, we have seen multiple operators, right? Relational operators and mathematical operators, all those things we have seen. Okay, so what you can do is you can take one particular operator, say for example plus, and then you can write a code in such a way that you can make that plus operator to act as minus operator. Okay, or you can make plus to act as plus as well as minus. You can do that. That facility is there in C++. You can do that. That is called as operator overloading. That is your C++ itself will give you that particular power to you, the programmer. Okay, it gives power to the programmer to define different what is the meaning to a particular operator. Okay, you can make plus to operate as plus as well as minus. Okay, that is called as operator overloading. or you can define multiple definitions also for a particular operator. Okay, that is operator overloading based on your context. So when the programmer is doing operator overloading explicitly, that is called explicit operator overloading, because the programmer is giving the different definition to a particular operator. We will not see how that is done. All those things are immaterial to us. We are learning Java. Okay, with respect to plus concatenation operator, this topic, yeah, that's why I'm just referring to it. Okay, but in Java, only one operator, that is plus operator, is overloaded. Okay, the power is not given to the programmer to overload this plus operator. Okay, so it is inbuilt in Java. That is why it is called implicit operator overloading. It is only done only for plus operator. Okay, don't consider any other operators. Okay, only for plus it is done. This is called as concatenation operator. Okay, so what exactly happens? So whenever you use an operator, right, you will have a particular operator operating on 2 operands minimum. Okay, say for example, I want to add 2 numbers. Okay, a plus b, or 10 plus 20. Okay, what am I doing here? I'm trying to add 10 and 20, right? So this is our operator, addition operator. This is our operands, right? Left and right operands. So Java, this plus is implicitly overloaded in such a way that, say for example, for if one of the operands, okay, if at least one of the operands is a string, as we are seeing here, we know that if you put some characters within double quotes, it's a string in Java, right? At least if one of the operand is a string, others are whatever it may be. Okay, even if it is an object, complex data type, that gets converted into a string. Okay, the condition is this is the condition. Okay, if at least one of the operand is a string, what happens to all these things? Say for example, okay, I'm trying to concatenate this with 10. Okay, what is happening? This will be considered as a concatenation operator instead of your addition operator. Why? Because this is one of the operands, this side is string. So what happens to this one? This is an integer, right? What happens to this? This automatically gets converted to string. Okay, I think I have explained this in one of our session. So this will be like, this is a string, okay, and 10. So the result will be this is a string 10. This will be the result. If you give a space here, or if you give space here, it will become this is a string, space here. Okay, now coming to this part. Okay, so how do you I want to print all these values, right? This A, B and C values. Okay, I can't just print say for example, let me take this example. Okay, I can't just print like this. Right? I can't print like this because I have not declared anything as any variable as with name ABC, right? So what I am doing here, I'll first print the value of A. Okay, so A will be replaced with our the value that is stored in A, variable A, that is 20. Okay, what happens now? It will be like this. Okay, 20. Now what I'm doing, this is not an integer, right? This is not an integer. So I just want to format this output in such a way that whatever the values that I have put here, right? A, comma, B, comma, C, right? Like that only I have formatted this. So these you can't include within your integers or anywhere, right? That's why I have, first I have printed the value of A, then concatenating this comma with string. You can't just put it like within characters. Okay, so like that. That is why I have used like this. So I have used concatenation operator because I can't. If I want to define only, if I want to print only value of A, I can just end. I need not have to worry about all these things, right? So just I'll print A, print B, print C. But I want to print it in this format. That's why I'm just using this one. Yeah. What was the question? Yeah. So Panindra is asking this question. So what he wants to do is, he wants to int x is equal to some 30. So here I'm for convenience I'm using just integer. Okay, it can be anything. Okay, it can be your float, it can be double, it can be any other data type. Okay, I'm just using but concatenation only with your string and other data types. Okay, so what is telling, I have declared x. So what happens if I want to print x plus string? Okay, let us see what happens. Where is x? This is the one. Okay, so what I told, the condition is at least if one of the operand is string, at least if one of the operand is string, the other operand will get converted into string and appended to the one of the other string. Got it, Panindra? So even if minimum two operands will be there, right, for a particular operator. Okay, there are situations where you can use only one operand. We will see when we discuss more about those kinds of operands. Okay, unary operators. They are called unary operators. Okay, so x is converted into string. Yes, correct. Okay, this particular thing is converted into this. Actually, we have yeah. Whatever the case, if at least one of the operand is string, the other will get converted into string. Yes. Okay. So yeah, that is the that is how the context of a concatenation operator is understood by Java. Okay, if one of the operand is string, the other will get converted into string, and then both the strings are concatenated. That is why it is called as concatenation operator. Okay. Okay, what happens if none of the operands is a string? Okay, so what happens if none of the operands is string? Yeah. So this is your result, Abid. Yeah. Okay. Yeah, that's an interesting question, Phanindra. So what is Phanindra is asking is, yeah, this is the question which Phanindra is asking. Can we do arithmetic operation inside print statement? Here, print is not a statement. It's a method which I have defined here. Okay. This is the method which I have defined here. Okay. So what I'm doing, I'm just doing system.out.println. Okay, print line. That's it. Okay, whatever the string I pass here, the same thing will be printed. Why I have defined that one? I defined because I don't want to type system.out.println every time. That's it. Okay. So what is your question? Can we do arithmetic operation inside a print statement? Let us see whether we can do it. What do you want to add? So let us see. This is the okay. So let us take a plus b. Value of a plus b. We don't know what are the values of a plus b. Let's see. Okay. A plus b. Or we can say x plus b. We don't know what are the values of x plus b. So what is the value of x plus b? The result is 70. Did we do addition here? Did we do arithmetic operation here? Yes. How did we do that? How did we achieve that? Using your parentheses. Okay. So what exactly is happening here? This particular expression gets calculated first or evaluated first. Okay. Then that result is converted into string and that is appended to your another string. That's what is happening. So we will see this particular this thing when we are discussing about when we discuss about various operators, right, exclusively. Right now we have seen relational operators and arithmetic operators. When we discuss about the operators exclusively, we will see about all these things, how to kind of like say there are set of like plus and minus have same precedence, right? And my division and multiplication have same precedence. Okay, when you put those things in one expression, which will get evaluated first and which will get evaluated last. Those kinds of things, we call it as operator precedence. Okay, we will see about all those things when we deal with the operators exclusively. Okay, it may be another couple of say for example in maybe 2 to 3 classes we will cover up all these basics and then we move on to our object oriented concepts. Okay. So what Hari Krishna is asking what happens. Okay, this is the question Hari Krishna is asking. What will happen if we remove plus symbol before x plus b? Okay, so what is this x plus? This is appending operator. Okay, so it separates your two operands. This is one operand. Okay, whether it's a addition operator or your concatenation operator is defined by your operands. Okay, if both are your the numbers are what to say integers or numerals, then that will be added automatically. Say for example, print x plus y plus a plus b. Okay, so I don't take numbers. Okay, at least we should have, because these two are numbers. The result is what? The result is also a number. Okay, integer. Okay, so what is this? This only takes print. Okay, so that is why let us make this like this. Okay, let's see what happens. It's an interesting thing. So let's see result. Okay. So what do you expect? What you expected out of this? It's an interesting thing. Yeah, try doing this one and see the result. You have seen that result, right? Try to analyze why we got 7070. Okay, that is you think and tell me why we got this 7070. Okay, with that arrow. Okay, why we got that 7070 with the value. Okay, what is your x? 30 plus 40 is your x and y, and a plus b is your 20 and 30. So tell me why exactly we got 70 and why these two things did not get added. Okay. One more thing is interesting thing is result. So did you get your okay? So just take these two things. Okay. X is equal to 30, y is equal to 40, a is equal to what is that? A 30, b is equal to 40. Okay, this is these are the variables declared, and this is the statement. Okay, you analyze and tell me why we got that result. The result is this one. Okay, that's what I want. Okay, analyze and tell me in the next class. Okay, so what else is there? Okay, so next is, so we call, so other important things related to scopes is, so what are we seeing here? Yeah, what are we seeing here? Okay, these variables, as the rule says, these variables are not visible outside of this particular scope. Okay, these variables are not visible outside of this particular scope. So that is what are we doing here? By defining a scope, we are localizing these variables within this scope. Okay, localizing means it is localized to this particular block, or it is confined to this particular block. These two variables are visible only within this particular block. So these blocks are called, these variables are called local variables, because not only these variables, any variable within a particular block is called as local variable. Okay, so why we call them as local variables? Because they are confined within a particular scope. Okay, they are confined within particular scope. That's why we call them as local variables, localized to that particular scope. Outside of that particular scope, the variables does not exist. Okay, that's why we call them as local variables. Okay, also just see what exactly is happening here. This is our class scope. Okay, this whole thing is our class scope, and this is our method scope. So what we have done here, within our class scope, we have defined our method scope. Okay, within our class scope, we have defined a method scope. So what does that mean? Actually, what we have done, we have nested one scope within another scope. That is, we take okay, what we have done, this is our class scope. Okay, class scope ends here. Okay, your method scope and method scope ends here. Okay, so what we have defined, so this is one scope, and this is another scope. So we have nested one scope within another scope. So by defining this one, okay, are you getting what I'm trying to tell? We can nest a scope within another scope. That means you can define one scope within another scope. Okay, you can define one scope within another scope. For example, you can define another scope also. See? This is also valid. Okay, this is called as nesting your scopes. Okay, nesting your scope. This particular scope is your inner scope. This is outer scope. Outer scope with respect to this inner scope. This becomes inner scope of this method scope. Okay, method scope becomes inner scope of your class scope. Okay, that means all these scopes are nested within one another. That is what is called as nesting a scope. Okay, so all these scopes are nested within one another. So there are four scopes: class scope, method scope, anonymous scope, inner anonymous scope. So what is the rule? If you declare a variable here, this is visible only within this particular scope. You cannot access outside of this particular scope. Okay, if you try to print it, it shows error. Right? It shows error. So outside of this, it is not visible. Okay, try to print this outside of this particular scope. Right? Again, it shows error. Okay, so outside of a particular scope, it's not visible. But can I print J here? Can I print J here? Okay, problem is this one. Can I print J here? Yes, of course I can print. See, I comma J is 10 comma 40 because the inner scope has access to the variables of outside scope. Okay, so any variable declared outside of one particular scope, right? Outside of particular scope is visible within inner scope. Okay, any variable declared outside of a scope is visible within inner scope, like J is visible here. So if I declare a variable here, it is visible throughout all this okay. X I have declared at the top of your method. Okay, immediately after your method declaration, I have defined X or declared X. Okay, so even if you try to have one more inner scope, all those things are visible. Okay, the innermost, all the values are visible. But the opposite is not true. This itself is not visible outside of the scope, as we have seen. Okay. So what it says, anything defined outside of the outer scope variables are visible within inside inner scopes. Okay. That's what we are trying to tell here. Anything defined outside of a outside of a particular scope is visible within that particular scope. So what it says, the outer scope encloses the inner scope. Okay, objects declared within the outer scope are visible in outside scope variables are declared are visible inside inner scope. Okay, but the objects declared within inner scope are not visible outside of it. Okay, that is the general rule which we discussed, right? Also, within a block, variables can be declared at any point. Okay, in some languages there is a restriction. Okay, you have to declare at the top of your method or function declaration. Okay, you have to declare all the variables at the top. Then only you will be able to access it. You can't declare anything in between after any other statement. Before you start any statement, you have to declare all your variables. Okay, that is what this particular statement says. That is this particular statement. Within a block, variables can be declared at any point. Okay, this is what it says. Okay, so that is, what does that mean is, see what I have done. So within this, I have declared integer. Okay, within this block. After all these statements are done, okay, after all these statements are done, I can declare another variable. Int ABC is equal to 30. This is allowed in Java, but in some other languages, this is not allowed. Okay, other languages, this is not allowed. So within a block, we can declare variables anywhere. So as I mentioned, variables are valid only after they are declared. Okay, variables are valid only after they are declared. Okay, and one important thing is, whenever you declare a variable, it defines a scope. Okay, whenever you create a block, it defines a scope. So we have seen that what we are trying to do here by defining a scope, this variable is not accessible outside of this particular block, right? So what are we trying to do? We are trying to hide this variable or data from code outside of this particular block. Okay, this is very important. Okay, so we are hiding this data. We are hiding this data from any code outside of this block. When we try to access that variable outside of this block, that becomes our compile time error, because this particular variable is not visible outside of this particular block. So what are we trying to do? We are trying to hide that variable, which is nothing but encapsulating the data. One of the basic concepts of object-oriented programming. Okay, so the block or scope defines the foundation of your encapsulation. Okay, this is very, very important. Okay, scope defines. This is what. Okay, so this is what it says. Like, scope provides the foundation. Okay, provides the foundation for encapsulation. It's the basic foundation for your encapsulation. Okay, so whenever you create a block of code, It defines an encapsulation. Encapsulation is nothing but data protection or data hiding. Okay, encapsulation is nothing but data protection or data hiding. So scopes provide, or scope defines the basic foundation for your encapsulation. Okay, we will see all this encapsulation, polymorphism, inheritance, encapsulation, polymorphism, abstraction, all those things while discussing our object-oriented programming concepts. Okay. So we are seeing like variables needs to be declared before they are used. Okay. Okay. Then let's move on to the method scope. Yeah, method scope, as we have seen, it begins with opening the curly brace and ends with when it closes. Okay, parameters declared within are included within the parameters declared are included within the method scope. So okay, so what does that mean is we have declared a parameter here. Okay, this is the parameter of main method. Okay, we can access. Can we access this particular variable within the main method? Yes, of course we can access. So what is the scope of this variable? String args. So it is similar to this one. Okay, what is the scope of this integer variable? Throughout this method, even you can access this variable. Okay, x is equal to 30. Okay, because we have declared at the top of your method. Throughout this method, throughout the scope of this method, we can access the x. Similar to that one, the parameters defined for a particular method are accessible throughout this method. Okay, can we access here? It says true. Is array length 0? True. So what am I trying to do? I'm trying to access args. Okay, args is an array. So we know that arrays are names used for storing multiple elements of same data type. So in integers or primitive data types, what we are doing is storing only one value for one name. One identifier stores only one value. But in case of arrays, we can use one name for storing multiple values of same type. That is very important. Okay. Yeah. Can I declare x at the bottom of a block? Declare at the bottom of block. You want to declare here. X is already declared, right? So it will give an error. Because it is visible throughout the method, right? So what he is asking is, can I declare x at the bottom of a block? So if you want to declare, you say he is telling x. Okay, let us try to declare something which we have not declared. A, B, okay, x, y. You want to declare, yeah, you can do that. So, but what happens is I have used somewhere else also, right? Say for example, let me try int x, y. Okay, int x, y. So now this says it is invalid. Okay, the same thing I have done. I will remove this. And can I declare here? Yes, of course I can declare. You want me to remove x only? Yeah, yeah, Panindra, I have unmuted you. Yeah, you can ask question.
Yeah, hi. I'm
Yeah,
looking like instead of removing, yeah, so we declared x equal to 90 on the top, right? In the block.
correct.
So, and we use that x value inside the blocks, inner blocks and
Yeah, we use,
anonymous code.
yes, correct.
Yeah. So
Okay, let us try
instead
it
of
this way. Let
declaring
us,
x equal to 90 on the top, if I declare x equal to 90 at the bottom of the block, and I will use
that,
the x before it. I mean,
yeah,
same
so this
code,
is,
but I'll declare. Yeah, that's what
yeah,
I'm. So
okay.
will this work?
Yeah, see this. X cannot be resolved to a variable. So here what we are trying to tell, yeah, this is the one, right?
Yeah.
This is the one.
Okay.
So you have to declare it before it is
We use
valid.
it.
I mean, valid means you can use it only after you declare it.
Okay. Yeah, I got that. So I just confirming, like you told, like we can use a declaration part at the bottom also. So I'm just checking whether we can do in this way or not.
Yeah, you can declare it. Okay, you can declare it. But the condition is, say, you have declared it. It is possible. You can
Okay,
declare it.
we have to
But
define
you
it.
cannot use it. Yeah, you cannot use it before declaring it.
Okay, so you meant to say that ABC equal to 20, I cannot use in the above code. I can only use
No.
after.
Yes, exactly. So if you want
Okay.
to, I mean, you can try that one. Okay, ABC. This is just for this one. Don't get confused. Yeah. See?
Okay. So first we have to declare and then only use. Okay.
Yeah. Print. You can print the value. Right? We can now we can print that value. So let us comment this. Okay? It says,
Yeah.
got it?
Yes, got it. Thank you.
So the condition is, yeah, sure. The condition is you have before using it. That is the only condition. Okay. You have to. You can use only, or variables are valid only after they are declared. That is the thing. Okay. We have to remember that. So another important thing is the lifetime. So what is this lifetime? So life is nothing but when the variable is created and when it is destroyed. That is what is lifetime. Okay. So as soon as the particular scope is entered and that particular you come to the statement part where you declare your variable, that is when it gets created. Okay, that is when the variable gets its life. As soon as you move out of the particular block, the variable will no longer exist. Okay, that gets destroyed. That is what is defined as the lifetime of a variable. Okay, lifetime of a variable. So who defines that lifetime of a variable? That again is your scope. Okay, within a particular block, your variable exists. After you move out of that particular block, your give me a second. After you move out of your block, the variable does not exist anymore. Okay, so that means the value we have seen, right? The value will no longer be. I mean, you can't access that particular value, or you can't even that particular variable itself is not available. Okay, let's see how we can see that particular thing with an example. Okay, let us try. Okay, let's do one more example. Let's try. Okay, I have declared variables. A is equal to 10, B is equal to 20. Okay. Again. Okay, so now what I will do, I'll create one more block. Int x is equal to 30. Okay. Okay. Let us see. Okay. Let's try to print another value. Okay. So this is our program. Okay. Let us see how. So there is something called as running a program in debug mode. Okay. So we use this particular icon, debug. Okay. Debug icon. Debug icon. So we run it as this application, Java application in debug mode. Okay. Click on it. Hold on for a second. So we'll have various windows for seeing what exactly is happening. Okay. So what I will do, I will define something called as breakpoints. Okay. So your program execution stops at these points. If you double click on each and every statement, right, you'll be able to see one particular dot here. Okay. So what exactly happens is whenever a program is running, starts to execute, you know that it starts from your main. So it comes here and stops here. Okay, till you take some other action. This is all what is called as running your program in debug mode. Okay, so there are other windows. I have just closed it. So this is one of the important windows. So you can see what exactly happens to this particular various variables defined in this particular window. Okay, let us run this in debug mode. Okay, it stopped at this point. Okay, so still variables int a and b are not defined. Okay, there are different ways in which you can progress further. You can just resume means F8, just press F8, it will go to it will start executing the next statements. Okay, till it encounters another breakpoint. Okay, it stops. Or if you want to kind of like go one step by step, right? You can go step over. Okay, so it goes to the next statement. This is one statement. This is another statement. Okay, now you can see first as soon as it entered your main method, args variable is declared. Your array variable is declared. As soon as it completes its execution of this particular statement, you can see two variables, right? A and B, and they are initialized with 10 and 30. Okay. Now closely watch what exactly happens. Okay. So this particular statement got executed, and I am able to see the result here. Okay. But still, this particular statement is not executed. Okay. The execution has stopped at that particular point. It actually stays on your breakpoints. Okay. Wherever you have defined your breakpoint. Okay. That is the line where you want to stop, right? You can double click on that, and you'll be able to see. Once you double click on that, you'll be able to see this particular dot that is in your debug mode. Okay, not normal running mode. So let's go to next statement. Okay, so next statement you can see x is 30. So you can see x is defined, and then it is initialized with value 30. Okay, let's move now. Just observe what exactly happens. See, I am out of this particular block. Okay, now can we see x here? We are not able to see x here. That is what is the lifetime of a particular variable. Okay, so as long as the execution code execution was within this particular block, you were able to see variable x. But after that, you are not able to see the variable x here in this particular window. Okay, so as long as this particular block is there, the variable x is visible as well as the value of variable x was available within that block. Outside of that, it is destroyed. It's no longer no longer exists. Okay, so scope defines the lifetime of a particular variable defined within itself. Okay, the particular scope, whatever the variables that you have defined within that particular block, right? Within that particular block, the variable is created, and as soon as you come out of that block, that variable is destroyed. I'm not sure whether you step back here for that. I'm not able to find it. Okay, fine. Yeah, you can go back also to the this particular block and then again start over. Okay, so that's what. So as I showed you, within that particular block, the variable exists. Now, once you come out of that block, the variable gets destroyed. It no longer exists. Because of that, you cannot access that variable. The variable defined within a particular block, you cannot access outside of it. Okay. So I guess that is what I wanted to cover for this session. It was actually like a repetition of whatever we covered in our last session. Okay, so whatever we covered in last session, I was not able to record the session, so I took a repetition class today. Okay, so we'll meet tomorrow again. If you have any questions, please send it to Intuition. Yeah, Abid has one question. What will happen if we initialize the same variable with different data types? Okay, that is the topic of our tomorrow's session. So in tomorrow's session, we will see what are the type conversions. Okay, what do you mean by type casting? Okay, so like there are two different types. Okay, the compatible data types and incompatible data types. Okay, so when you use type conversions, compatible type conversion, like based on that one, like compatible data type conversion and incompatible data type conversions, we have different things: implicit type conversion and then explicit type conversion. Okay, so we'll discuss that tomorrow along with the arrays. We'll cover arrays, single dimensional arrays and multi-dimensional arrays, along with the type conversions and type casting. Okay, for explicit type conversions, we use what are called as typecasting. So how to do typecasting, all those things we will see tomorrow. Okay. Yeah, any other question? Okay, yeah. Let us wind up this call and we'll meet tomorrow again at 8 p.m. CT. Okay. Yeah, thanks everyone. Thanks for asking questions. So please keep asking questions. If I don't know or if I can't answer to your questions at any point in time, I'll definitely get back to you. Okay. Thanks again. Thank you very much.